Hello, everyone, and thank you for joining this session on thriving in the cloud beyond the 12 factors. My name is Grace Jansen, and I work in the IBM development lab here in the UK in a place called Hursley. If I don't get around to answering any of your questions throughout this presentation, then please do feel free to reach out to me on Twitter. My handle is there. It's at GraceJansen27. So without further ado, I'm going to jump straight into this session and I will be checking the chats as we go. So let me know if there's any questions that you have throughout the presentation, and I'll try and answer them as soon as I can. I will be keeping an eye on that. So do feel free to add questions whenever you think of them. Great. So in order to look at sort of how we can build applications that thrive in the cloud, we first have to look at how we've evolved our cloud infrastructure and thus how we can take most advantage of that. So in order to get to the stage that we're at in terms of our modern cloud infrastructure, when we compare it to what it used to be, we used to be running on sort of single core, but now we can take advantage of multi-threading and multiple cores. We have virtualization and containerization. And all of these have allowed us to be able to build extremely responsive applications that are able to scale dynamically and that are able to provide better experiences to our end users. And that's because as our infrastructure evolved, as we developed these different sort of technologies, I guess you'd call them, like virtualization, like containerization, and all of the underlying cloud infrastructure as well, we also evolved our applications. So we went from sort of a more monolithic type of application where all our code was bundled up into one often very large application. We then went and broke that down into either microservices or macroservices, or even as far as functions, depending on what stage you're at and what kind of application you're building. And by breaking down those monoliths, we were able to effectively separate out the aspects of our application into chunks, which meant that if we were able to, if we could identify bugs easier, we could essentially roll out new versions of a particular component within our application without having to take the entire application down and then back up again. And this all helped us to build more effective cloud native applications. And it got us getting quite excited about what the cloud could offer us going forwards and how we could best take advantage of it. It led to kind of this, if you've seen Toy Story, you might be familiar with this sort of, ooh, the claw, but in my case, the cloud. So why are we so excited about the cloud? Why are we striving? And why have we been striving for so many years so far to really get our applications to be cloud native and to take advantage of these evolution and the innovation coming out of the infrastructure involved? Well, cloud offers various different sort of benefits. Some of the benefits include things like cost. So the fact that you're essentially outsourcing that cloud infrastructure to a third party means that you should be getting economies of scale. They're doing it for lots of customers, so they should be able to do it much more cost effectively and pass some of those cost savings on to you. It enables speed and scalability. So you should be able to rapidly provision resources as and when you need them for your application's loads. So if you have a high load, you should be able to increase the resources assigned to your application to better deal with that load. But also when that load decreases, you should be able to rapidly scale that back down to be cost effective as well. It also enables resiliency, scalability, innovation, because you're being able to make use of that cutting edge infrastructure that these companies are providing, flexibility, but also fashion. So you're able to provide the innovation that really gets your customers excited because it enables them to perhaps have a more resilient application to use, as an example. So we're striving for all of these benefits that the cloud offers and trying to make it the most of them by really building applications that make full use of the cloud and that don't just survive in this cloud environment, but really thrive. So what does it really mean to build a cloud native application? What is it to be cloud native? Now, there's loads of definitions online. You can look at various different vendors and they'll all have their own definitions. I've taken this from the CNCF, and as the name suggests, they're sort of experts in all things cloud native. So this definition really talks about how cloud native technology should be there to empower organizations to build and run scalable applications in these modern dynamic environments, whether that's a public, private, or a hybrid cloud, it doesn't really matter. It's all about, and if you want to see that definition in more detail, I've included the link here as well. It's all about utilizing those technologies in building your application so that you can achieve the various behaviors that we've been talking about. I took lots of the definitions that I found online and put it through a word map to come out with sort of these key benefits and key characteristics we want to be seeing when we're building cloud native. And these are the key behaviors that came out of that word map, came out of all these various different definitions. It's about building applications that are loosely coupled, that are scalable, like we said before, resilient, speed. These are all benefits that we were mentioning with the cloud. Having observability, being able to do this all rapidly. We live in an agile environment now, so we need to be able to be responsive and have rapid deployments, not maybe a deployment every year, for example. So it's really about how can we build our applications to be exhibiting these behaviors, which is what we want when we're running in the cloud and what it means to be cloud native. And that's where methodologies like the 12-factor app methodology can really come in handy, because not only are they technology, language, and platform agnostic, but it really helps to set out the various different components or elements or steps we need to be considering if we're going to be truly and successfully building a cloud native application that is ready to thrive in the cloud. So some of you might have come across the 12 factors before. It has been around for a while, but it is still very much relevant. It's a methodology that was originally defined by developers at Heroku, and it was designed as a methodology for building cloud native applications. So the original, you can actually head over to the 12factor.net website if you want to find out more about it. The original 12 factors are the ones listed here. So we'll go through some of them in a bit more detail when we look at the 15 factors, but these were the original 12. Now, this sort of methodology has been around for at least 10 years or so. So there have been iterations to it over time as our cloud infrastructure has evolved and as we've sort of learned more about what it really means practically building cloud native applications and perhaps other considerations that weren't necessarily maybe thought of or included in the original 12 factors. And that's sort of where this evolution to the revised 15-factor methodology has come about. So this 15-factor methodology is from an author from Dynatrace called Kevin Hoffman, and it's loosely based around those original 12 factors, but there are additional revisions to some of the original factors, and there's also 3 additional new factors, like I mentioned. So the ones highlighted here are the new factors that have been introduced, and the others, you might notice some of the titles here have been edited slightly. So there are some revisions to the original factors as well. So we'll take a look at each of these factors and how the factor can be, why it's important firstly, what it is, and how we can enable that in our applications, what technologies we can use to enable that, and then where this all fits in the bigger picture. So thriving in the cloud through these revised 15 factors. So we'll be going through some of the 12 factors, as I mentioned, but also those additional new ones too. So the first factor. Now, I've tried to make this easy to see which factors are new and which factors are sort of just revised versions by having this bar at the bottom of my slides. So if you see a sort of orangey reddy color, this means that it relates to an original factor. If you see a dark blue color, it means it's a new factor that's been added. So it also gives you the name at the bottom, if it was an original factor, of which factor it relates to. So the first factor we have here is called one code base, one application, and it comes from the original factor code base. So this factor is all about the fact that cloud native applications should always consist of a single code base that is tracked in a version control system, and that code base is essentially your source code repository or a set of repositories that then share a common root. And it can be used to produce any number of immutable releases. Now, where this has sort of been revised from the original factor, it's quite similar, but you can see the addition here is the fact that we've specifically stated that ratio of one code base to one application. So it's about this one-to-one relationship between application and code base, but a one-to-many relationship between code base and deployments, as you can see here in the various different environments that you might be deploying to. Why do we have this factor involved? It's essentially to support collaboration between development and various other teams. It enables us to have proper versioning, and it enables us to have faster time to market. So how do we enable this factor? Well, there are various different technologies, and you're probably using some of them already. So things like GitHub, GitHub Enterprise, GitLab, There's also alternatives like Bitbucket or SourceForge, and there's also cloud-specific platforms like AWS Code Commit or Google Cloud source repositories. So you might be using any number of those, but they're just some of the technologies you can use to achieve this factor, many of which you're probably doing, many of you are probably doing this already, but important to consider that sort of ratio as well. The next factor is factor number 2, which is API first. As you'll notice, this is a new factor. So this factor, actually, I should note first, something to note about some of these factors is that they don't always necessarily map to specific physical requirements imposed by the cloud. Some of them are more about habits of people or organizations in building cloud native applications. Because actually, when you think about building cloud native apps, it's not just about the code itself. It's also about the culture within your organization. You know, are you set up to be able to deploy every 2 weeks or whatever, to deploy rapidly, to deploy microservices? Are your team set up to build microservices? So it's also important to consider those habits and behaviors of the people in the organization as well. And that's where some of these factors relate to as opposed to the code themselves. So this factor here is a new one, and it's all about sort of really putting the API first. So it's about giving teams the ability to work against each other's public contracts without necessarily interfering with the internal development processes. So API first means what you're building is an API to be consumed by client applications and services. So this whole factor was introduced because we are working in essentially an ecosystem at this point. If you're developing an application for the cloud, the ultimate goal is for that application to be a participant in an ecosystem of services. That might be you're connecting to external third-party services or just your own services. But essentially, you've got multiple services all deployed in the cloud, and you're working in this sort of ecosystem now instead of a monolithic application. So if the APIs aren't clearly defined, this can lead to a nightmare of integration failures. So to avoid these integration failures, this API-first approach gives teams the ability to work against those public contracts without needing that interference. So it's really about sort of having a consistent and reusable approach to creating and developing these APIs by using things like API description languages to establish that contract for how the API is supposed to behave. And you can establish that contract by spending a bit of time thinking about the design of the API first. So instead of just rushing into development of the API or development of your application without even thinking about how you're going to connect all these services together, instead, take a moment in the design phase of your application and really think, okay, how is my API going to be structured? How am I going to describe that API? How am I going to connect my services together? And this is where that factor comes in. So why is it important? I've already mentioned a bit of that already, but it essentially helps to avoid those integration failures. And it helps to formally recognize your API as a very important aspect of development of your application in these cloud native manners. It enables greater collaboration between your various different stakeholders. If you're designing your APIs first before you've even coded, it gives you a chance to mock them up and to see, is it appropriate for all of my stakeholders? Is it appropriate for the various different services connecting in? And if it's not, you've not wasted much time. You can go back to the drawing board, redesign the API, or perhaps tweak or edit the API. And it means that you're going to be much more effective going forwards because you've already mocked it up and you've already had that collaborative sort of testing with your different stakeholders and services and that ecosystem. And yeah, it enables you to test or verify that direction in your plans before you invest too much into it. So how can we enable this? How can we be good participants in this ecosystem? Well, the first thing is to share your public contract. And you can do this through technologies like using OpenAPI or the API Blueprint. These are open source specifications. So if you're interested, go ahead and check them out. You can also utilize tools that then implement these open specifications, like, for example, MicroProfile OpenAPI. This is the first time I've mentioned MicroProfile, so if you've not come across it before, there have been a couple of talks at this conference actually already on MicroProfile, so I definitely recommend going and checking them out for yourself. It is essentially a community-driven specification designed to help those building Java enterprise applications to build more cloud-native applications. So it enables various different components and APIs to help you with that. One of which is MicroProfile OpenAPI. So go and check it out if you're interested. I've included a link. You'll see sometimes I put links up. They essentially are links to guides if you want to get hands-on with the technologies that I'm describing within these slides. You can also use proprietary products if you don't want to go down the open source route. And there are a couple like Apiary and IBM's API Connect tools. So a very important new addition to the 15 factors. The third one is dependency management. So you're probably very familiar with this. In classic enterprise environments, we were sort of used to this idea of having this mummy server who would essentially provide everything that our applications needed, take care of their every desire, whereas our applications have had to grow up. They've had to mature because we've moved to this cloud native environment where they don't necessarily automatically get everything they need. We have to then provide that ourselves by utilizing dependency management systems. So this is quite similar to the original factor, which was dependencies. You can see at the bottom there. This is all about explicitly declaring and isolating application dependencies using things like declaration manifests that are stored within our code bases, and using things like dependency isolation tools when we're doing things like application execution. Why is this one important? Well, it helps us to provide consistency between our various different environments, whether that's dev, prod, testing, whatever. Helps us to simplify our setup for developers that might be new to the application, and it helps to support that portability between various different cloud environments, because we're not just assuming that it's going to be in every environment we might be deploying our application to. So it really helps us to have that flexibility and that portability, which is obviously very important in cloud native systems where you want that flexibility. And it enables greater dev productivity. So how do we achieve this one? Well, the first thing is to explicitly declare and isolate your dependencies. So instead of packaging third-party libraries inside your microservices, specify your dependencies in for example, if you're using Maven, a pom.xml, or in Gradle, a settings.gradle file. And this really enables you to freely move up to newer versions and, as I said, that portability. So you can use tools like Maven and Gradle, which can be really helpful to enable this factor. The fourth factor is very similar to the fifth original factor, which is the fifth one was build, release, run. That was the original factor in the 12 factors. It's now design, build, release, run. So we've just added in that design element. So essentially, this whole factor is about explicitly separating out the design, the build, the release, and the run stages. And it's important because we're trying to prevent changes to code or configuration at runtime, which then might in turn lower the number of unexpected failures. So it enables us to be much more efficient in terms of our release management. It enables us to have maximum delivery speed, while also importantly, keeping high confidence through our automated testing and deployment model. So the only real addition here was the design phase. So when we say design phase, this doesn't necessarily mean that we're designing everything at the start and then we're going through the build, release, run. This design stage is really a continuous process. So we design sort of small features that might get released. We have a high level design sort of from the start, but that design might change over time, depending on various different external and internal factors that we might need to change aspects of our application. So it's about having this high level design that is used to inform and sort of lead everything that we do, but also to bear in mind that design changes and that small amounts of that design are part of every iteration rather than all being done upfront. So it's during this design phase that arrangements are made to sort of declare dependencies, think about that API first approach, and how those dependencies are going to be vended or bundled within the application. The build, the release, and run stages are fairly similar to the original 12 factors. So, your build stage is where your code repository is essentially converted into your artifact. Your release phase is where it's typically done by pushing to your cloud environment. And it's essentially the output of the build stage is combined with the environment and sort of app-specific configuration to produce another immutable artifact called a release, hence the name for that stage. And then you've got the run phase, which is typically done by your cloud provider. And the details vary depending on which provider you're using, but the general pattern is that your application is essentially placed within some kind of container, whether that's Docker, Garden, Warden, etc. And then a process is started to then launch your application. So that's all remained the same. It's just that design phase that's been added. How can we achieve this? Well, you might want to consider using something like a CI/CD pipeline, like something like Tecton, to be able to make this sort of continuation along this process a little bit easier. The fifth factor is configuration, credentials, and code. Now, this one is very similar to the original factor configuration, but as you can see, we've now explicitly stated that we're also considering credentials and code within this as well. So the original factor stated that we should be storing configuration in the environment, but this updated factor is a bit more explicit. In this updated factor, configuration really refers to any value that can vary across deployments. So that might be URLs or other information about backing services, information necessary to locate and connect databases, credentials to third-party services, or any information really that might be bundled in properties files or configuration files, etc. Now, the reason credentials has been explicitly mentioned here is because really we've had an increase in awareness as we've been developing cloud native applications and our processes have been evolving, that actually some of the time credentials have accidentally been stored within code repositories or source code. And credentials are extremely sensitive information and should have absolutely no place in a code base for obvious reasons that we don't want our software hacked. So the golden rule here is really that we are thinking about configuration, but explicitly credentials, especially, so that we are making sure that we are externalizing these so that we can write once and configure everywhere. So what is this about? What this factor is about? Strict separation between code and configuration and storing that configuration in environment variables. Why do we bother with this? Well, modifying application change behavior without making code changes is one benefit of this. We're able to simplify deployment to multiple environments. Remember, we're going back to that flexibility when we're deploying to various different environments, but also different cloud providers as well. We can reduce risk of leaking those credentials and passwords, making your applications more secure, and it enables more effective release management. So how do we go about doing this? Well, first things first, extract all your application config to environment variables and make sure you are not including credentials in your source code. Microprofile config, so coming back to microprofile again, can be really helpful in this. It enables us to place configuration in properties files that can then be easily updated without recompiling your microservices. So you can also make use of things like CDI injection to then directly inject a set of properties. So you can make use of both microprofile config and microprofile CDI. So again, I've included a guide there if you want to check that out in more detail, but that's just one open source sort of component that you could use for this. The next one is logs. So this is very similar to the original, called the same name, logs. So this factor is all about treating logs as event streams. So a truly cloud native application should never have to concern itself with routing or storage of its output stream. So you should be logging to something like stood out or std only. Why do we bother with this? Why is this included? It's basically to make logging a platform concern and not a developer concern. It should not be your application's responsibility. And that's because this enables us to have improved flexibility for introspecting behavior over time, and it enables us to have this real-time metrics that can be collected and then analyzed to then improve our application in the future. How do we go about achieving this factor? Well, as I mentioned before, you should be logging only to stood out or std. You should be treating your logs as event streams, and you should consider the aggregation, processing, and storage of the logs as a non-functional requirement that should be satisfied not by your application, but by your cloud provider or some other tool suite running in collaboration or cooperation with your platform. So tools might include things like the ELK stack, so Elasticsearch, Logstash, Kibana. You might be using something like FluentD, Splunk, Sumo Logic, or any number of tools to capture and analyze your log emissions. So that one sort of remained fairly similar to the original 12 factors, but still very important. Another one that's fairly similar is disposability. Again, same name, same concept. So an application cannot scale, deploy, release, or recover rapidly if it cannot start rapidly, but also shut down gracefully. So we need to be building applications that are not only aware of this, but also embrace it to take full advantage of this platform. That's, microservices should be fault tolerant and should be able to function under any situation. And we should be able to rapidly bring them up, but also shut them down. This factor is all about maximizing robustness via these fast startup and graceful shutdown behaviors. It's about treating apps, I've got an analogy here, as cattle and not pets. So if you think about it, if you have a pet, you've given them a name, you have an emotional attachment to them, they're unique, and you lovingly care for them. Even when they get sick, you nurse them back to health. That isn't necessarily the behavior we want in a cloud native instance, because that's going to result in, your application essentially being maybe faulty, unresponsive. You're trying to nurse it back to health, when in fact, it would just be easier and quicker and more effective if you could gracefully shut down that microservice, not cat in this case, and replace it with an alternative, healthy working microservice. So actually, it's more like cattle. Cattle are given numbers, not names. They're almost identical to all other cattle. That's what we want on our microservices. And when they get ill, you just replace them, sadly, with another one. So really, we should be looking at more producing cattle microservices, not necessarily pets. So in order to achieve this factor, we should be minimizing our work on startup. We shouldn't be depending on things like shutdown hooks. We should be maximizing our robustness with really fast startup and automated scaling. Something that can help with this is microprofile fault tolerance. So microprofile fault tolerance essentially enables us to build in fault tolerant behaviors. So if, for example, something were to happen to our application, then we might be able to basically have some behavior in place. So let's say our microservice goes down, our behavior is to just gracefully shut that down and to install another one. So fault tolerance enables you to place that within your code and determine what that behavior should be. And this one allows us, as I said, to enable fast and elastic scaling, rapid deployment of maybe new config or code changes, and provide robustness in those production deployments and auto scaling. So a really important factor. Then we've got number 8. Number 8 is backing services. So backing service is essentially any service on which your application relies for its functionality. It's a very broad definition, and that's deliberately. Its wide scope is intentional. Some of the most common types of backing services include things like data stores, messaging systems, caching systems, and really any other type of service like perform line of business, functionality, or security. So this factor here is all about treating these backing services as something called a bounded or attached resource. And that just really means it's a means of connecting your application to a backing service. So for example, a resource binding for a database might include a username, a password, and a URL that then allows your application to consume that resource. There should never be a line of code in your application that tightly couples the application to a specific backing service. So that's why they should be bounded. There should be a bounded aspect to it. So this is very similar to the original factor. You should be making no distinction between local and third-party services. They should all be bounded backing services. And you should be attaching resources via those URLs, like I mentioned, stored in your application's configuration. Why are we bothering with this one? Well, it helps us to enable that loose coupling. If you remember back to those cloud native behaviors, that word map that I showed you, loosely coupled was a very large aspect of it. We need to have loose coupling between the various components in cloud native in order to be resilient and responsive. So this factor enables us to enable that loose coupling between service and deployment. No code changes should be required to then update those backing services, and it allows operators to swap out services as and when they see fit. It really enables resiliency and agility to be able to attach and detach bound resources at will when we need to. How do we do this? Well, as I said, you just need to treat backing services as attached resources, and microprofile config can help with this. As mentioned, a lot of this is to do with configuration. So we can enable microprofile config for that. Number 9 is environmental parity. Very similar, slightly different to the original factor, which was called dev prod parity. So this factor is essentially all about keeping every environment. So the original factor only really mentioned dev and prod, whereas the revision to this factor is basically saying, no, it should be every environment that has parity between it, whether that's production, staging, QA, DevSecOps, developer environments. They should all be as similar as possible. It's about having sort of discipline and applying rigor to your environmental parity in order to give your team and your entire organization really the confidence that your application is going to work no matter where you deploy it. So some organizations have done more evolving, and many of us have likely worked in an environment like the following. So you might have a shared development environment that has a different scaling and reliability profile than QA, which also might be different to production. The database drivers that you might use in development and QA might be different to production. There might be security rules, firewalls, and other environmental configuration settings that are also different. And some people might have the ability to deploy to some environments, but not to others, so they can't test it in every environment. And the worst part of all is that people start to fear deployment. They have very little confidence because of these differences between the various environments. They have very little confidence that it's going to work no matter where they deploy it. So really, this is why we need this emphasis on keeping that consistency between every environment. This factor helps us to lower the risk of unexpected errors, to support continuous deployment, and enable greater reliability and resiliency. How are we going to achieve this? Well, we should ensure that some backing services are used for all deployments. We should ensure a solid continuous integration pipeline and deploy to production as often as possible. And I should say as often as reasonable. Automated CI/CD pipelines can help with this. And also things like container tools. So for example, things like Docker can help make prod-like environments more accessible to developer workstations through testing tools like microshed testing, which is essentially a way of utilizing Docker containers on your local machine to be able to test as you would be sort of deploying in production. So make it as close as possible. If you want to check out more about microshed testing, then again, there's a guide here that you can check out to do that. Then we've got admin processes, which is very similar to the administrative processes they've got here. What is this factor? Well, really, it's all about running admin or management tasks as one-off processes. It's about storing code for those admin tasks within the app's code base. And why is this important? Well, it enables us to have safe debugging or admin of the production applications and enables us to have that greater reliability again. Kubernetes tasks can be really useful for this. Or alternatively, you could use something like AWS Lambdas, for example. Number 11, port binding, very similar to the original port binding. This is essentially the principle of port binding really asserts that a service or an application is identifiable to the network by a certain port number, not by its domain name. Your cloud provider, again, this is going back to separating out what's the responsibility of your application and what's the responsibility of your cloud provider. Your cloud provider should be managing the port assignment for you because it's also likely managing things like routing, scaling, high availability, and fault tolerance, all of which require the cloud provider to manage certain aspects of the network, including routing host names to ports and mapping those external port numbers to containerized ports. So an application developed with exported port binding in mind really supports the environment-specific port binding without having to change any code. Why do we care about this one? Well, it enables really great ops efficiency. The reasoning is that domain names and associated IP addresses can be really assigned on the fly by manual manipulation and automated service discovery mechanisms. How do we go about doing this? Well, we can export services via port bindings. Microprofile config can help with this, for example. You can specify the new port in Kubernetes config map, and then microprofile config will automatically pick up that value to then give you the correct info in the deployed microservice. You can also use things like microprofile REST client, which is another of the APIs, which can help with creating client code to connect from one microservice to another. So again, microprofile coming in very handy here. And again, most of the sort of tools that I'm mentioning in this presentation are open source, so you can go and check them out, have a go yourself. Stateless processes is the next one. This relates to the original factor, processes. So this factor is all about executing the app as one or more stateless processes. In the 15-factor book, this is argued that it should be a single process, but I would argue it doesn't necessarily have to be. So microservices should all be stateless. One way of doing this is REST, which is a very well-adopted transport protocol, and JAX-RS can be used to achieve a RESTful architecture. So systems that really follow the REST paradigm are stateless, and in this way, the underlying infrastructure can then destroy or create new microservices without losing any of the information. So you should ensure that all stateful data that you need is stored in a backing service somewhere, not within your microservices themselves. And all long-lasting state should be made external to the application, and again, provided by that backing service. So the concept isn't that state cannot exist. You can have state within your application, is that it shouldn't be maintained by your application itself. It should be maintained by those backing services. Why do we care about this factor? It helps to reduce deployment complexity reduce operational complexity, and allow for much simpler scaling and cloud compatibility. How do we go about doing this one? Store any stateful data in backing services, like I've mentioned before. Don't use things like sticky sessions or the local file system, please. Do not use in-memory caches. Store any in-memory cache that your application thinks is always available. It can bloat your application. It can making each of your instances take up lots more RAM than is necessary. So really, we should be trying to follow this as much as possible. And you can utilize things like, again, microprofile. You can utilize things like Redis, for example. So you can use third-party caching products. Some of them include things like Gemfire or Geode is the open source version, Jcache and Redis, and all of them are really designed to act as a backing service cache for your application specifically for these needs. Then the next one we have is concurrency. So this relates to factor 8 in the original, which is, again, concurrency. It hasn't changed that much between the two. This is essentially all about scaling out via the process model and treating those processes really as first-class citizens. So concurrency advises us that really cloud-native applications should scale out using the process model. There was a time when if an application reached sort of the limit of its capacity, the solution was just to increase its size. If an application could only handle some number of requests per minute, then the preferred solution was to simply make the application bigger. But actually adding CPUs, RAM, and other resources, whether that's virtual or physical, to a single monolithic application is essentially vertical scaling. And this type of behavior is typically frowned upon in our sort of society these days. A much more modern approach, and one that's ideal for the kind of elastic scalability that the cloud supports, is to scale out horizontally instead of vertically. So rather than making a single big process even larger, you instead create multiple processes and then distribute the load of your application among those processes, as you can see here in the graph. So that means essentially microservices should be able to be scaled up or down depending on that workload. That's what concurrency is all about. So it allows for easy horizontal scaling, auto scaling, and we can enable this by really splitting out our app into separate runnable processes and scaling those independently. Tools like Kubernetes Autoscaler can help with this. Number 14, this is one of the newer ones. So we're getting towards the end of our factors here. So this is telemetry. So you might think, well, I've already heard of logging earlier in the presentation. That was already a factor. Why have we added telemetry here? So logging is a really great start, but it generally is a tool that you're using during development so that you can diagnose things like errors or code flows. It's typically orientated around the internal structure of your app rather than reflecting that real world customer usage. So that's really where telemetry comes in. It's how you collect data once your app is essentially released into the wild. So it wasn't among the original 12 factors, but it has been added in these 15 factor application methodology. So this one, why do we care about this one? Well, modern applications are far more complex than they used to be. These applications and supporting environments are composed of hundreds, if not thousands of microservices often, they're highly dynamic, distributed, and they scale automatically to meet users' needs. Applications are more important than ever. All companies have applications that are mission critical. So if these applications aren't monitored and the performance degrades or crashes, revenue is at stake and customer satisfaction. So there could possibly be bad press, call outs on social media, or even just poor customer satisfaction that leads to potential revenue loss. So it is really important that we do monitor our applications to ensure everything's working as it should be. Customers also expect more features more rapidly, and only monitoring can really give you the real-time feedback you need to quickly understand how customers are reacting to that new feature and if its performance is optimal. So that enables us really to introduce that innovation that our customers are now expecting. And it enables our cloud applications to be audited and constantly monitored. Things like microprofile metrics and health can help with this. These are two other components within microprofile which can enable this telemetry. The last one is authentication and authorization. So this wasn't really discussed in the original factors, and that was probably, this is about adding security in, really making security a forethought when we're designing our applications and emphasizing its importance, really. Security is a really vital part of any application and cloud environment, and it should never be an afterthought. A cloud native application has to be a secure application. And so this is where things like authentication and authorization can come into play. So it's about adding additional security to applications through the use of authentication and authorization methods of users. And it enables us to really increase that security of our application. How do we go about doing this? Well, we need to be securing our endpoints, and we can use things like RBAC, so role-based access control for that. We can also use tools like OAuth 2, OpenID Connect, Keycloak. There's lots of others that you can use as well. We can also make use of things like microprofile JWT, JSON Web Token, to help to authenticate and authorize and verify users. So again, some open source in there as well. So now that we've sort of whizzed through all of the 15 factors, where we've added revisions, where we've added new factors, how does this all fit into the bigger picture and enable us to actually create cloud native applications that thrive in the cloud? Well, let's take a look at sort of a general mapping of an application and sort of the development process involved. So here we have just a generic app. We might be pushing to a public or a private or a hybrid cloud. It doesn't really matter. We've got some backing services involved running in the cloud, and we have this arrow going along, which sort of loosely represents our delivery pipeline. We've got things like repositories that we're going to be pulling down artifacts from, or publishing artifacts, etc. So you can see that in the diagram here. So let's lay on top our 15 factors. So here you can see where these factors fit into that development process, and you can see where they relate to the various different stages of development and stages of deploying that application. And then if we add on top of this diagram, map on top some of the behaviors that we want to see, or that we have to see for an application that really wants to thrive in the cloud, we can see how some of those factors actually enable those behaviors. And if you're sort of keen hearing, you can hear that actually I've been dropping them in throughout the presentation. Enabling loose coupling, enabling resiliency, observability through things like that telemetry and logging, enabling scalability and rapid deployment. So enabling these factors becomes fairly easy by following those 15 factors laid out in that methodology. And actually, if we remove all of the words from this and take a look at some of the technologies I mentioned for each of those various factors, we can start to see how these technologies can help us in building a truly cloud native application, regardless of how you're building it, whether it's a macroservice, a microservice functions, even a smaller monolith. As long as you're following those factors and really enabling those cloud native behaviors, you can utilize technologies like this to create that. And you can see how you can make a really cloud native application that thrives. So if you're interested in getting hands-on with any of the technology I've mentioned throughout this presentation, then there are some interactive cloud native labs that you can take a look at. They are based on the guides that I've put links to throughout this presentation. And actually, we're running a workshop tomorrow as part of this conference. So come and join us there if you're interested in taking a look at these and having us lead you through them. As I said, they're based on the OpenLiberty guides. OpenLiberty is our open source web application server, and we have a whole website there for you to take a look at with documentation and these interactive guides for you to get started with. They interact with many of the technologies I mentioned throughout this presentation, so check them out. So hopefully, in summary, what I've shown you is that the 12-factor app methodology is a great place to start. But in order to really thrive in the cloud, we have to look beyond the 12 factors, and that there are no excuses. There are loads of open source tools and technologies that are available to help you with this and to enable you to achieve those factors and achieve truly cloud native applications. So an action for all of you today: evaluate your own applications against the 15 factors I've gone through in this presentation and consider, what could you do to enable them to truly thrive in the cloud? Are there any factors you're maybe not doing or maybe could improve upon? And how could you go about doing that? In case I haven't given you enough resources throughout this presentation, if you want some more resources, I have 2 slides here with some general resources, but also some specific to some of the factors that I've mentioned throughout this presentation if you're more interested in getting deeper into those. So hopefully that's useful, and I'll post the slides online in case you didn't get a chance to screenshot them during this presentation. Thank you very much for listening, and I believe we have a few minutes for questions. Thanks very much. If you have any questions, feel free to put them in the chat. I am looking at the chat now, so I can see there. Thank you to Dawn, who said nice analogy. I'm glad you liked it. However, if you don't feel comfortable putting them in these questions in the chat now, that's totally fine too. You can always ping me afterwards on Twitter. Glad you enjoyed it. Thank you very much. And I believe there's also some education that will be posted. Yeah, here it is on Open Liberty. If you did want to get some training on Open Liberty, then check out the education that's been posted in the chat there. Yeah, if you have any other questions, feel free to ping me on Twitter. Thanks very much, guys.